a semi-synthetic fiber. Among that, there is so many rayon fibers are there, such as viscose rayon, fusraminium, high tenacity rayon, and then di and triacetate fiber. And then the completely synthetic, that is the main we can say, and that is domain control of a human being, that is polyester, nylon, acrylic, monoacrylic, polyethylene, polypropylene, Kevlar, Nomex, Spandex, Stefan, etc. So that means we have a series of range of fibers, and again natural, semi-synthetic, and man-made fiber. Let's understand as we go through the fiber and polymer. Then if we give the one statement that is all polymer is a fiber, so statement it can be might be not true. But if you say that all fibers is a polymer, yeah, that can be possible, because if you focus on the properties of the fiber, then we find that it is a units of matter which describe the flexibility, fineness, high ratio of length to thickness to the diameter. It has also the characteristics of a long chain molecule, more or less parallel arrangement of molecules, and it has the effect to make the things that is cohesion. So if it is a long fiber, cohesion will be more. If and then it will give the better strength and better property. If it is a short fiber, that is a staple fiber, we generally known in the textile arena, that means it has the cohesion is less, and because of that, it is not giving the good structure and property. Now let's have a look on few of the properties of the fiber in a pictorial way also. So cotton, among the natural fiber from the plant source, cotton is playing a very crucial role. Then we have a jute, banana fiber, bamboo fiber, and the coir fiber. In nowadays, if you think for the banana fiber, we have also now after the jute, this is playing a very crucial role even in the hygienic material. We have created for the sanitary napkin, that is a biodegradable pad, that is from the banana fiber, and nowadays it's a low cost at the same time, very much demand with the customers. In the bamboo, also natural bamboo has playing a very crucial role, as it has from the nature it has a self antibacterial, UV resistance, and other coolness property. And coir also playing a very crucial role in the packaging material and the yarn industry. But please don't mimic the bamboo with the synthetic, or say the rayon bamboo. So sometimes we are cheated with the rayon bamboo in our day-to-day life also. Now sometimes we have find the statement that the cotton is known as the king of among all the fibers. And if you go with the silk, it is known as the queen of the fibers. So now the question comes, why the cotton is the king of fiber? Because it has a lot of advantage, at the same time the properties which is gift of our mother nature, that it has a good moisture absorption, wicking property, that means water intake property is very good, which makes it most comfortable fiber. If you go with the processing side, it has a very good high weight strength, which is advantageous as well as for the processing side. Now, in the case of the cellulose, we have found that the basic unit is a celluloid, and if you go with the alpha and beta, we have the cotton. In the cotton case, it is a beta cellulose we have found. So that is which consists of the two beta glucose units which bound together by 1,4 beta glucosides linkage. So this is the unit, or we can say the chemical structure of the cotton fiber. Now come to the details about the cotton property. It has also the sideways linkage, that is a hydrogen bond. If you go through that, this because of this hydrogen bond, it finds gives very good strength during the wet condition. Once the cotton fiber you wet in water, you will find its strength is increased. But that is not case for the other fiber naturally. Then only after the cotton, only linen fiber has this property, and because of that, only it has a good demand in the case of the summer season. But it has again the restriction that cannot be knitted. It only the woven material can be possible from the linen material. So it has a good property of the hydrogen bonding. Then it has a operative condition, that is a crystalline region is there, and also as well as the amorphous region. We know that if it is amorphous regions are more, it is good in absorbency, is good for the dyeability sites also. But at the same time, we require the crystalline because of the strength and as well as the good structural property of the fiber. In the case of the natural fibers, we have the protein fiber, which is the wool and silk is the source. Among the wool and silk, we have found there are so many amino acids, and because of the amino acids rich in source, it is also known as the polyamide group fiber. And because of that amide group, it is a actually it is mimic to our human hair also, and we know that in our human hair also it is a many amino acids are there, and it has a very good for the fastness, at the same time has a lot of applications. If you go through the India, then we have found most of the south except Kerala, we have found the Mulberry silk is there, and then categorized of the Sasar, Muga, Eri, these silks also there. So that means we are rich in silk, and at the same time, always we are given more focus on the mulberry silk. Now, if you move towards the semi-synthetic fiber, viscose rayon or viscose fiber is always coming first whenever we go in that arena, because we human beings always try to mimic the our mother nature and try to do something better, or we can say try to do something which we can control in our hand. So thinking in that, keeping the cotton's all the properties in mind, we have generated or we have developed the viscose rayon fiber. So what we have done, we have found that it is a raw materials which consists of the cellulose that is mostly from the sparse pine trees and the other trees where it is actually rich in cellulose. It is also a higher chain length than paper cellulose, and it has gives through this process. So it is actually going through the weight spinning process, and we can see this video. This is a weight spinning process where the viscose rayon after the gel, it has been passed from the coagulation bath, and it has been then it's solidified and conducted into the as a fibrous form. So it is actually because that is done in the coagulation bath in a wet condition. That's why it is known as wet spinning process. So this is the viscose rayon process. In this way, the most of the rayon fibers has been generated similar to the viscose rayon. The soybean rayon fiber, then the acetate, dry acetate, then the bamboo rayon also nowadays has been doing in this fashion, and we have found that it's giving the lots of application. Now, if you go with the modification, so regular rayon that we have come to know. So in the regular rayon, this is really a comfortable fiber. We have achieved almost all the qualities that cotton possesses, and even the better than the cotton. But one property that cannot be achieved in the viscose rayon or the regular viscose rayon, that is the weight strength. Once it's deep in water, its strength loosens. That's why it is not fit for the summer season, for mostly for the inner garment. So that's why we need to modify the regular viscose rayon so that we can improve the weight strength. So that's why high weight modulus rayon nowadays we have developed, and high tenacity rayon, then cupra ammonium rayon, which is actually banned in USA because of the ammonium content, and then acetate rayon. So many rayons nowadays have been developed based on keeping this mind. And there's also other lots of applicants, starting from the yarns to the fabric, and then the rubber industries, as well as the tire cords and all that. Now, if you move to the synthetic fiber, that is the polyester, nylon, acrylic, these are always in demand because of the application. Wherever we go for the blend, because of the cost to reduce, we always prefer the cotton polyester blend also. So these are the few evolution in the 20th century. If you go in 1935, the nylon has developed, the 1937 polyurethane, 41 polyester. Then actually a terylene and dacron is a polyester, but it is because of the US and UK different products. It is named as a terylene and dacron. 1944 acrylic, and then 51 it is a polypropylene and high density polyethylene has been developed. Let's have a look few of the properties of the polyester varieties. So actually major polyester fibers are dacron, that is a USA, and terylene is a UK. So based in this country, this name has been there. So they both are chemically same, but dacron end group is acid, whereas the terylene end group is ester. So because of that, this name has been different. But ultimately, the end product that we get, that is a polyethylene terephthalate, that is the same. So this is in the case of the polyester, we are developed this fiber with the help of the melt spinning process. So let's understand the melt spinning process with a small video. So this is a melt spinning process where the most of the synthetic fiber can be generated, polyester, polypropylene, nylon. So these are the within this process. This is a polymer chip of a polyester. So we can extend the fiber length based on the denier, means fineness, how much fine we want. Based on that, we give the stretchability, and then after the solidification, it's collected onto the bobbin, and in this way, the most of the synthetic fiber we can generate with the help of the melt spinning process. So now this polyester fiber as a yarn form is collected onto the bobbin, So this is the process of the milk spinning process, and we developed the fiber. I hope video is visible. Can anyone just give me?
Yes, sir, it was visible.
Yeah, and audio is also there, no, in video.
Yeah,
Means,
yeah, yeah,
is it
yes, sir.
audible? No? Yeah, thank you. Okay. So now we move to the nylon 6. Actually, it is first produced on 1935 by the Wallace Catos at the DuPont company. And actually, it is a raw material, is a caprolactam, which has a six carbon atoms, and because of that, nylon 6 has name. I hope you all of you know about it. I'm not going in detail. And nylon 6 is also because of it is also the first man-made thermoplastic fiber is there, and it is a lightweight, windproof, stretchy, and Capsules of a DuPont also has developed the nylon 6. So what is the raw material? Adipic acid and hexamethyl diamine is actually mixing together, and we found the nylon 6, which is a chain of six carbon molecules linked to a chain of the six more carbon molecules. And because of that, the 6 name has been given. And it is now a polymeric chain which has a lot of application. Similar to the polyester as is visible in the video, this is also produced can with the help of the milk spinning process. Now move to the carbon fiber, which is nowadays has a lot of application. Wherever you move, we cannot live without carbon. If it is a mobile cover, laptop cover, whichever materials, even the aerospace, in every sector, the nowadays carbon fiber has given. And because of the graphite whiskers, the carbon nanotubes, which is again the given the birth of the in 2004, that is the graphene, that is actually from the graphite which has been produced, so which is nowadays also creating a very wonder to the textile in the chemist and at the same time the materials science. So it is actually how it's produced. Let's have a look on it. So I hope it will be more understandable. So it is a carbon fiber production. So I hope this is the process, development process the carbon fiber has developed. And if you go with the few of the information of the carbon fiber, BMW car that we have shown in our life, that is actually there the hood and all the outer cover material body is actually of a made up of carbon. And nowadays their research is going on, R&D is going on combination with the graphene and the carbon fiber so that they can improve their functionality. And they try to make the in the hood of the car they try to introduce the graphene material so that the capacitor they can act as a capacitor and that can be given as a battery insulator so that the light and all the actions can be performed with the graphene help also. So this is R&D is going on at the same time. The Samsung and other companies also try to focus on the graphene material. Now we move to the acrylic fiber, which is actually again DuPont Corporation has been created the first acrylic in 1941 and trademarked them as in the name of the Orlon. So as an acrylic fiber, it is actually at least 85% by weight of the monomer, that is a polyacrylonitrile, that is a PAN. And if it is a modified, that is, it has been known that it's composed of less than 85%, but at least 35% weight of the acrylonitrile unit should be there. Then in 1987, Thai acrylic fiber by the Aditya Birla Group, they have again come with the acrylic fiber, and nowadays they have also getting a very good market on the acrylic fiber. So if you go with the preparation of polyacrylonitrile pan, it is a polymerization. We make it with the solution polymerization, and with the help of the acetylene and hydrogen cyanide, we can make the acrylonitrile. This is one reaction, and again ethylene oxide and hydrogen cyanide. Again with the another reaction, we can go with the acrylonitrile. So based on this monomer, we can go with the polyacrylonitrile, and then we produce the acrylic fiber. So chain initiation, chain propagation, and then termination. In this way, we go for the acrylic fiber production. In the case of acrylic fiber, we can go with the wet spinning technique, or also we can, with the help of the dry spinning technique, also this fiber can be produced. It has also a very good application in the apparel, home furnishing, industrial application, and as well as the other applications also. Now move towards the essential properties or the performance which is required for the fibrous material. That is the aesthetic properties, which is the foremost. That means it has such as a touch, sight. In the case of the aesthetic, we can also think in the, or we care for the luster, drapability, texture, and the hand. That is a feel. If you go with the certain fiber that we discussed with the brighter and the lustrous or matte, in the cotton, we will usually find there is a matte like look or luster property. The cotton also, with the help of the bleaching or moisturization, we can improve the luster, but still it's not giving such as brighter or as lustrous property as silk. Most of the synthetic fiber we have found it is a lustrous property. Durability is also a very much big parameter. There is aversion, resistance, tenacity, tensile strength, tearing strength, that overall bursting strength, which is much more required during the parachute tent fabric. So these are the parameter properties which is required to make the textile fiber, so that we can contribute for the high tech material as well as for the apparel material. Now, comfort is a very big, it's also a priority. So keeping that mind, whether the fiber is a hydrophilic, that is a water loving, or the hydrophobic, there is a water phobia, that also we have keep in mind, and based on that, its absorbency of water or dyeability has been done. Again, the density and the thermal retention property is also playing a very crucial role. As we think for the example of wool and acrylic, which gives the highest thermal retention, and because of that, it's very good for the winter season. Because of the large air pockets in the case of the wool, it gives a higher degree of the thermal insulation property. And if you go with the reverse, the cellulosic fiber, that is cotton, in the example, which has the lowest thermal retention and thus preferred choice in the summer season. So these are the properties which is required, and based on that, we give for the applications and the end use application of our day-to-day life. In appearance-wise, dimensional stability, shrinkage, elasticity behavior, these are also keeping in mind. And if you go with the other properties, there is resistance to the chemicals, light, environmental impact, which is also we have to keep in mind, fair properties, and the cost, which is really creating a big matter on the production house, and that there is the fabric and the fashion. Then we identify the fibers with the help of the burning test. As we know that cotton, jute, and most of the cellulose fiber, once it's burned, it smells like a paper. And if we go with the wool and silk, there is a protein fiber. Once it's burned, it smells like our burning like a human hair. And similarly, the other fibers also has a property like that. Then we confirm for the confirmatory test. We try to think on the solubility test of the fiber. I take the example. The 75% H2SO4 we can is deep in the cotton, that is a dissolve, that is a solubility confirmatory test, and whereas in case of viscose rayon it is a 60% sulfuric acid. So that means based on different fibers have different percentage, different chemicals. So based on that we can identify the fiber. Now we can move towards the another zone, that is how from the fiber the fabric is developed, and from the fabric the garments are manufactured. So let's have a look on this arena. So now we understand few different fibers: natural, synthetic, semi-synthetic, and synthetic. Once if it is a synthetic fiber, then directly with the help of the wet, melt, or the dry spinning, we convert it into a yarn. But if it is a natural, then this fiber making a impart a twist, and with the help of the ring spinning and other spinning technology, we convert it into yarn. Once the yarn has developed, after the yarn, we convert it into the woven fabric. That is the interlacement of warp and weft. For woven fabric, it requires minimum two sets of yarn. For knitted, single thread can be possible to make a knitted fabric. And in the case of the non-woven, that is actually it is a process directly from the fiber to fabric. Non-woven, we can develop it. Here, the yarn is not required. Then in case of the woven, we have lots of application and knitted also. So let's understand few of the woven examples in our day-to-day life. This is the bed sheets, the setting, suiting, tapestries, wall hanging materials is actually the product of the woven fabric. These are the few products. That is where the loops has been the phenomena, warp of the web knitted loop. It is actually the product of the knitted material. How we can easily identify now for the woven and knitted? If you go with the woven fabric, the stretchability is less if it is not the lycra material. And in case of knitted, only because of the loop structure, its stretchability is a good number. So I hope in day-to-day life we are taking the both advantage. But in case of knitted, much more preferable for the sportswear, for the t-shirts and the other comfortable materials. We have also developed with the weave, that is a design playing a crucial role in making the weaving, that is a plain or the basic weave that is there, that is mostly in the setting, and the few derivatives such as poplin in the dhotis and all that. Basket, which is also known as a Oxford, that is 2 into 2 design. Then mat weave. Twill weave, actually, it is minimum 3 sets of yarn is required, and it's mostly used for the trouser and the pants. Denim, that is actually a product of of one down twill weave. And in denim, you will find that it is actually not a fabric dye, it is a yarn dye. Only one set of yarn has been dyed, that is known as warp. That is a blue denim color indigo dye, that is a bad dye. And the another set of color is undyed. And because of that, we find the product that is if you reverse the denim fabric, you will find that is a white on structures is more. So because of the two up one down structures, that is a phase one. So we find the blue color, indigo blue color is a more, and that back it is a color. So that is a denim, is a twill weave. Then we have a satin weave, that is a warp prominence. If it is there, then it is known as satin weave. And these are the few materials of satin. Then satin, that is a web prominence. If web thread is much more in the there, so it is giving you this type of material, and it is 100% cotton or rayon, mostly choice for this type of design. Then Georgette, which is mostly fine, that is in everyday life we wear it. That is actually a lightweight crepe fabric, originally made from the silk with a highly twisted yarn. So that's creating the crinkle surface, and because of that, we have find it is a very good drapable at the same time comfort also. In the case of chiffon, it is also a lightweight silk crepe. A twist in the crepe yarn puckers the fabric slightly in the both direction after the weaving, and giving it some straight and slightly the rough feel. So chiffon fabric is slightly rough as compared to the Georgette. Now move towards the apparel and garments. Let's first segment for the menswear which we are using. Here we'll focus which type of fiber we are using in such of that segment. So that's my main motto to show that particular thing. So let's have a look on it. It's mostly it made of the cotton, as we know, the comfortability because of that. Sometimes also the viscose hybrid modulus, then blend with the certain materials. In the case of the soft, polyester or nylon is mostly the preferable. In the menswear, shirt is mostly polyester, cotton, or the blend of the both. Viscose rayon also playing a very crucial role. Then in trousers, also again the blend of the fibers, cotton, and other synthetic materials also creating a role. In the case of the shirts, we have a different designs. That is it can be striped, it can be checked, it can be printed, it can be single monocolored dyed material, or it can be white color. Now, in the case of the apparel, which is mostly made from the blended fabric, it might be single, but mostly in the case of worsted, we know that because once we find the blazers are costly, if it is a worsted, because it is actually a wool, but it is only comes from the merino wool, which is found in the country Australia. And it is very costly because its length is bigger than the normal woolen length. And because of this bigger length and the very good property, it's most of the choice for the blazer in the apparel garment. Sometimes we have found the polyester cotton blend and other viscose blends also, the apparels in our day-to-day life. Mostly the blends of the polyester, viscose, cotton, and the worsted, we prefer 67-33, 70-30, and other ratio is also preferred. Most of the industry prefer this type of ratio for making the blend. Now, men's denim wear, if we focus, we know that most of the branded industries nowadays focus on the finishing such as flame reparency, water repellent, antibacterial. So Levi's, Paper, and Spiker, we have found this, they are focused on this type of material. At the same time, the lycra, that is actually a stretchable material, spandex fiber. There has been introduced with the woven material so that the stretchability we can got it. And nowadays it will find a lot of application in denim industry. So this is a men's denim industry, and here we find the laser printing also, and nowadays has a creating a very crucial advantage where we can the cutting, the fading, and all the things can be possible. So this is a laser technique on the denim industry also nowadays has been done, and this is the way easily we can give the effect and the fading onto the material. So this is a laser cutting technology, and nowadays this technology also has been introduced in the wood where the any number or anything can be also impressed. So this creating this is a very doing within a very small duration of time. We can give up, we can cut it, we can give an impression and the effect on the denim fabric. So in this way we can cut and then we can go for the stitching. Now in the women's denim wear, now also we have nowadays find a lot of applications. These are the few fashionable. In the case of different washing techniques, we have polypropylene spraying that helps for the denim fade. Then the pumic stone, acid wash, enzyme wash nowadays, that is a cellulose enzyme, has playing a very crucial role. In the women's innerwear nowadays, they find the lycra has been introduced in order to give the comfort, and the synthetic materials such as polyester also with the help of the blend with the cotton. Nowadays, also we are keeping in mind for the antibacterial property and other properties so that we give the maximum hygienic protection to the material. In the case of the trouser or the pants, we have found that cotton and the blends of polyester has been mostly used. In the women's wear, again, we have found that skirts such as cotton, viscose, blends of the polyester, cotton, and viscose are mostly used or preferred. In the lycra that we introduce in for the stretching, stretchable material, but we have to keep in mind we should not go more than 5%, max to max 7%. Otherwise, the stretchability property will lose, and we have found the shape and the size is not for the longer duration we cannot retain it. The women's wear segment, the sari is no doubt always a choice, and within the sari, the silk sari that is 100% mulberry silk is always a choice for the ladies wear. And here nowadays the antibacterial, stain resistant, these are the properties also given, and this is the logo so that the people cannot be cheated. So if this butterfly logo will be there in that particular silk, that means it is a 100% silk fabric, mulberry silk and other. If it is not there, that it might be it can be other materials. Mostly nowadays, silk fabric can be easily produced with the help of the polyester. 5 to 6% of NOx, sodium hydroxide, if you treat the polyester fabric onto it, you will find that is this luster has improved, and because this phenomena is known as weight reduction of the polyester, and because of that, it almost mimics like a mulberry silk. And nowadays, this is known as art silk or the China silk, and they are creating a very good market. So this is actually not a silk; it is a weight reduced polyester. So please be careful. That's why main purpose behind this logo I am showing it. And this is actually China silk, which we can taste it because it was for burning or solidity. So lots of taste are there. But still the symbol is a much more a phenomena where we can think for it. Again, in case of the woolen wear also, it is the wool mark. If it is a pure 100% wool, then this mark will be there. It will not happen in the case of acrylic. As we know, in a winter season, mostly we have fascinated with the acrylic fiber also. But sometimes we are cheated with the woolen. So actually, acrylic is a man-made fiber as we have discussed it. So please be careful with the logo. Otherwise, it is very difficult to judge visually whether it is a woolen or acrylic fiber. So we have the jackets or the coats, which is made up of the leather or the resin materials, and it is also playing a very crucial in the protective of the winter season. Let's have a spots of the garments where it is used. Actually, this is much used in the case of sports, and mostly the knitted garments is playing a very crucial role. Here we have find that it should be elasticity is a one parameter, everson resistance, high strength, high tensile and tear strength, and keeping all the parameters in mind, we have find the lots of the use of fibers material for the application. In the swimwear, we have find the nylon, spandex or the lycra is the most preferable choice, and it should be the fastest to chlorine because we know that most of the sea water or the swim water, the chlorine has been given so that the water can be clean. And most of the dyeable material or most of the fibers is not good for the they're very sensitive to chlorine. So we have to be always think on that whatever we use. So chlorine bleach, less water absorbent. The trade suits of gym wear we have find a cotton or the micro denier polyester, which is actually again we have reduced it or modified the polyester fiber used in the cotton so that it gives the more comfort along with the lycra. Nowadays, it has been used, and we have findings are very customers are very satisfied with that particular fiber. In the sports industry, also nowadays we have find the after the leather, it is a fiber such as polyester, polyester viscose, polystyrene, cotton, nylon has playing a crucial role, and at the same time, it has been used and giving the good property. If you move towards the high-tech fiber, nowadays Kevlar, then Nomex, then few or more polytetrafluoroethylene and all that stick. These are the fibers which are used and bulletproof jacket, and then high fight RNC. All these fibers are very, giving a very good property. Nomex and Kevlar also has a very good fight ardent. At the same time, it is very durable. So most of the high-tech material has been these are the materials used in the high-tech industry. Now, move towards the new segment, as the ma'am has also given me that if it can be possible for the few research and technology dimension. So I'm moving towards a few of the research where we can think as a chemist, as a polymer, as a fibrous background. There is a lot of scope in the fiber industry, in the textile industry, in the fashion industry, where we can do something. But always we should keep in mind that profit at any cost should not be there, and the chemicals which are using that should not be creating any effluent problem. So innovation is always required for, in order to make the life happier, comfortable. But we should always keep in mind. I hope all of you have watched this movie. Uh, yeah, can anyone name which is the clip of this movie?
Three
Anyone from the
Idiots.
audience?
The Three
Three idiots.
Idiots.
Okay, thank you. So I hope now you can give. Can you give me the incidents if anyone remember what they want to say here? They try to show the fountain pen. This is actually, and then the answer is come that in the space, if you go give it the fountain pen, that can be right. It cannot be the ball pen. And there is a response that is the if the graphite can also work. So why I'm showing this, it is actually like an alert to the young generation that we should always keep in mind whatever already developed. We now the time has come where we can apply it always to find something new, and we forget about the application, that is also not good. So which is already exist in our day-to-day life, we can, if you think for the application base, that really give a big matter. And so that means if graphite can work, why we should go for the discovery of a fountain pen for the space and invest lots of money on that particular research. So this is the message. Let's have a look on this video here from the bottle that which we thrown away, it can be converted into the polyester fabric. So this is also one step for the sustainability that we can create instead of raw chips. We can do this for the polyester industry. So I hope now you understand that from we have lots of things which is actually a waste, and that's why I've chosen that topic that is a waste from the waste. Actually, we have lots of waste, and at the same time with the nature there are lots of scope. So if you focus on that, we can find a lot of scope. And basic keeping in that mind, I prepared this slide as ma'am has also suggested if it can be if we can do something for the research world also. So ma'am, I think we can you allow me 10 minutes more so that I can so that glimpse of that particular
Yes, sir.
slide.
Yes, sir. Please go ahead.
Because I think whatever time you have given, I have completed what as you have requested and guide me. So based on that, I'm better. So can I move ahead for 10 more minutes?
Yes, sir.
Thank you, ma'am. Thank you. Okay. So now let's have a look on the few of the diversity of the fibrous polymer that we can do it. That is one of the word is the tissue engineering, then lotus leaf effect, coloring crystal without dyes, state memory polymer, and application of plasma. These are the few gap in the fibrous polymer research, and we can do a lot of things. So let's have a look on it. That few of the one or two examples I've shown you. In the case of human injury, we know that lots of burn and the heart blockages are there, and that means the treatment is really a very issue for that, and we create so many problems, shortage of the skin in case of the 90% burn, and also the shortage of the organs for transplantation, and these are the always worries in our the we can say the doctors arena and the medical area. So in the textile or the polymer or the tissue engineering is the biggest solution nowadays and the area where we can think. So in the tissue engineering, we have developed the scaffold by making the fiber in the solution stage with the help of the electrospinning. And what we have developed, now we can do instead of taking the original skin, what we can the PLA and the other fibers or the nano fibrous gel material has been developed and creating a layer onto the skin. So this is computable to that particular material or the scheme, and it takes time. And then after the time, wherever it is required, we apply it, and then we have found with the secondary electron microscope image that it has after the certain days, the RBC, WBC, and all that has been developed, and they have moved towards that particular material. So that means it's creating a issue of a skin problem. So we do not now require for the original skin this fibrous material can easily be do with that. So nowadays this type of issues can be easily done, and we help the technique of a salt leaching, 3D right assembly, and the nano weight. So with this nowadays it is actually the sodium alginate fiber is also nowadays used because it is a very good source of antibacterial. At the same time, it has a means itself it can be computable with the skin in a very faster rate also. Now, if you go focus on the nanometer, we know that what is a nanometer? Everyone 10 to the minus 9. So that if you compare it with this, let's compare it with the human hair. So that is actually a human one single hair, and this is the nanometer. So all of you know that is a 10 to the power minus 9. So why I have shown the nanometer? Because in the case of the electro spinning technology, we can develop the nanofiber, and with this nanofiber, we can do a lot of applications that is required in the different sectors of our life. So if we can do the milk spinning, that is a polyphenol now 6 is polypropylene. This is actually with the help of machinery we produce, but in the solution spinning, that is with the help of the electro spinning, dry spinning, wet spinning, and dry jet, we can produce this type of fiber also. So nowadays, new technique that is electro spinning, with the help of that, we can produce the polyethylene, polypropylene, nylon 12 also can be produced, polyurethane, polylactic acid, PLA, PVA, this type of fibers can be done with the help of the solution electro spinning nowadays. So how we can done with the electrospinning? So these are the four parameters which are playing a very crucial role. That is the applied voltage, polymer solution, concentration, and flow rate. So what happened? These are the few references. There we will understand if the change in the polymer solution viscosity. So if a low viscosity, the bead formation. If it is a high velocity, then if we find the fiber formation. So it has been well reported in this literature also. If it is a low concentration, smaller diameter. If it is a high concentration, larger diameter. So based on our end application, we focus on the thing. If it is a low flow rate, it is a smaller diameter. If it is a high flow rate, we find the larger diameter of the fiber. If we give the low voltage, then we find the larger diameter, and if we give the high voltage, we find the smaller diameter. That means parameters playing a very crucial role in order to making the materials, or we can whatever the products we did. And we can find about it to the live the applications of electrospore nanofibers. There is biosensor, drug delivery, wound healing, scaffold, filtration, conductive nanowaves, wires, protective fabric. So I hope this is also a very good area where we can the most of the PG students and the PhD students can think on this area, and it really has a very good electrospinning nowadays technique. We can easily develop in our lab and do a lot of applications. So this is the one with the help of electrospinning. Even the filtration, also we have found in the case of the electrospun fiber, there is a dust particles easily can be blocked. There is a red spot is a that is a minor pore of the dust particle which is easily can be blocked with the help of the electrospun fiber. Now, if you come to the lotus leaf effect, that is actually we know in our day-to-day life that lotus leaf has a water repellency property, and if you go with the same image, then we will find actually the lotus leaf viscosity looks like this. It is not like that. In our during the childhood also it seems to be that it might be there is some plastic layer is there, there's a coating layer, but actually it is not a coating layer. It is because of this structural phony type of structure. The water molecules instead of breaking it out, it actually roll it out from the surface of the lotus leaf. And keeping in this mind, we have self-cleaning effect and water repellency effect has been developed in the textile world. So if it is a lotus effect surface, that means the whatever the dust and molecules are there, it can easily take and it is move away. But if it is a smooth surface, it dust and the dirt cannot be taken out. So water molecules easily passes away. So keeping these parameters in mind, we have developed a lot of application in textile also and finishing. One more phenomena that we have find in our real life, that is a optical interference. So let's example of a peacock feather. It is also a similar example you will find in the butterfly feather also. So actually we have find the very attracting color it is, but it is not a dye, it is not a pigment. Actually, it is because of the optical means totally the light theory. Based on that, we found this attractive color. So that's why if you boil it, if you try to extract the color from this, you cannot extract the color. So because it is actually a night flower. So what happens? It is actually due to the Barbiel effect. So this is a rearrangement of the feather. Because of that rearrangement, we have found such type of effect. And we have to go with the microscopic image, that is secondary electron microscope. So this is the one image, and then more magnification in the 1 micrometer. We found this is actually the structure of a peacock feather. This is actual structure. And keeping this mind, what we have done in textile materials, we have take the different fiber, synthetic fiber. So polyester refractive index we know that is 1.6, and nylon has a 1.5. So what we have rearranged it, and we know that if it is a small difference in the bandwidth, so based on that bandwidth, we find the color. So we have rearranged it and layers of the 70 to 90 nanometer, and keeping that we start with the blue color and then other fiber and the other color. So based on that, the different colors we have found only with the rearrangement of the fiber without doing any addition of color on the pigment. One more, that is a safe memory polymer. It is actually nowadays very much applied on the surgery. So that is actually inside surgery. We do not nowadays take it out. We just get it and we heal the whatever the medical science application we require. And as it is a biodegradable, so it is compatible with the skin, and slowly it is compatible with our skin, and we not to take it out. So nowadays, safe memory polymer is also a very good area for the chemical industry or the chemist for giving a lot of to the medical field. One more area, that is a plasma, that is the fourth state of matter. So after the solid, liquid, and gas, that is a plasma. It is also nowadays introduced in our physics, that is a class 8 or 9 syllabus. Nowadays, no, we did not say that is now three states of matter. Now we say that is a four. We have a four states of matter. So plasma, as it is an ionized gas, it has a positive and negative charge, and because of that, we can create a lot of applications. So in our day-to-day life, lightning is a source of plasma. Solar corona is a source of plasma. The volcano, it is also a source of plasma, and based on that, we can also nowadays creating in a lab the artificial plasma, and we applied on the lots of applications. And the textile also, the hydrophilicity, hydrophobicity, fire retardancy, and lots of other medical applications also we are doing in the plasma application. Now, one more area, there is a biotechnology where we can think, and there are lots of scope. As we know that whatever the process we have, lots of wastage are there in the textile mills, particularly in the chemist side, deciding, clearing, bleaching. These are the processing field, and these are all the pollutants, possible pollutants of the textile industry. And keeping this mind, these are the results, pictures of the processing industry and the textile industry, as we are not keeping the mind of the eco-friendly chemicals. So these are the few complexities always there in the textile of the processing time, pH, temperature. Yeah, but at the same time we have to keep in mind. So biotechnology is nowadays is a lot of good scope. For the textile applications wise and the processing industry also. So let's have a look on it. It has a good scope on the enzyme textile processing, catalytic synthesis, coloration, and the effluent treatment. What is enzyme? I hope all of you know that it is actually a biocatalyst, and it's not playing rate of the reaction, but it's helping. So if you take this example, this is actually a lock and key mechanism. So this is actually an enzyme, and this is an active site example of a cotton. So it creates whatever activity we do. After that, enzyme as it is, it go away and it change the molecule. So part of a molecule changes, but enzyme is itself not a change. That's why it's known as a biocatalyst. And in our day-to-day life, in our body also, lots of enzyme is there. So that means it as a, that because of this beauty and as it is also eco-friendly, we have tried to develop it as it is a very target-specific substrate, accelerate the reaction, biodegradable. So we can now try to focus on the processing side of textile, that is a deciding. So amylase enzymes are now developed for deciding, pectinase for biostarring, catalase for bleach cleanup, cellulase enzyme for biopolicing, and nowadays cellulase enzyme is very good, much more preferred in the denim industry for threading of the denim instead of premix stone. So deciding actually it is a removal of side which is used in the case before weaving, and it is highly energy consuming, large consumption of water. So in the case of enzyme deciding, we have found it is no damage to cellulose fiber, and with the help of the that enzyme, it easily can be done. Scouring is a process with removal of the hydrophobic non-cellulosic component from the uh, uh, before the dyeing, and it is actually a highly resource consuming. And without that, bio scouring we can easily help both in acidic or alkaline media, also in the moderate 50 to 60-degree temperature. So pectinase, cutinase, cellulase, protease, xylase, and lipase enzymes serve well in this type of things. Then the bleaching, in the case of bleaching also we have found that hydrogen peroxide bleaching is no doubt it is eco-friendly, but at the same time the NOH that is we use is also not beneficial in the effluent problem. So enzymatic herbicide nowadays we use, and it's also giving a very good effect. Biostaining nowadays has been done in the case of the most of the bast fiber rating process. That is actually the microbial rating of the bast fiber, which is the first biological process used in textile processing since before time. So nowadays, first is dew rating and anaerobic rating. So nowadays, pectinase enzyme for giving a very good role in order to making the bast fiber rating and with a very good effect. Old scouring also have a very good with the help of the xylane and the pectinase enzyme. In the case of silk degumming also, we have found the prolactic enzyme which is used over the alkaline and the surf solution, so that we get a good effect. At the same time, effluent formation is not there. Nowadays, microbial colorants means that can be developed with the plant and animal end, and can be go for the dyeing. So with the help of the enzyme, now the coloration can be also possible. Effluent treatment also nowadays also has been possible with the help of the enzyme. So now let's focus on the different angle of a research also. If you think the biomimicry in the fibers is very important. In designs and structure, I've given you examples that whatever developed till now, we have it is actually taken from the nature. Even the law of gravitation is actually the falling of the apple, and the Newton's Newton has been developed the law of gravitation. So that means the nature has all the things. So think the example of weaving, the coconut leaf seeds, the wasp weaving spider's web that is actually from that come. Then we have found that is a plain weave structure that is of the weaver bird net. Nona when there is actually the mulberry silk cocoon, and then there is a tube housing the catopod marine worm. Then we have the Axicum lappa, that is actually the Velcro has been taken from that concept. If you go with the structural coloration of a butterfly, it's also giving the complex hierarchical structure, and it is also actually not a diazer pigment. Actually, it is due to its arrangement, this color has been found. So from nowadays, because of this arrangement, we have found the staging in Japan has developed this fabric, which is actually different source of light. In the presence of that, the color has been changed. With the help of the dolphin, the shark skin, we have also nowadays pseudo fast skin SS2 has been developed, and most of the swimwear suits has been now been keeping in mind and has been taken care. Then in design in the fashion industry also, biodiversity is a lot of playing a crucial role. Now, do we have a lot of natural and the dyes and for the dyeing as well as the finishing? Among that, we have a minerals, insects, plants, and microorganisms. So we have lots of like example of few of the natural resources. So that is a sticky your groundnut testa. So that is the outer skin has a good potential for coloration, as it has a rich in active biomolecules, and because of that it gives the coloration, ultraviolet protection, as well as the antimicrobial properties. So it is a 100% eco-friendly process, not consuming lots of raw materials, as well as the cost-effective process also. So these are the few products that is done with the roasted peanut skin. Then the chickpea, similarly, we have developed, and the students of our college, they have done with the room temperature with the cotton, silk, and wool. And then any trees bark has also lots of potential to give the good coloration, as it has a very good source of the phytochemicals, that is saponin, tannin, then flavonoids, terpenoids, and because of that, it has a very good fastness as well as the coloration property also. So these are the eucalyptus bark. Now come to the coconut shell extract, that is the part of my PhD research. This is a wastage coconut has been taken, and because of that, we have extracted out the water among it. What is actually this from this portion? So this water is actually evaporated if you kept it for 2 to 3 days, and it is not used at all. So we extracted the water molecules from it, that is itself a pH 4.5, and we convert into with the help of the carbonic acid, that is pH 7 or the um, 10, and then we use as a boiling with the fabric, and we find a multifunctional property. It gives you a coloration, fire retardancy, antibacterial, and UV resistance. So coconut shell extract has lots of potential in order to that. So as we know that is water has lots of potential. That's why these are nowadays if you go there are 60 70 rupees for one coconut green coconut shell. But it the thrown away part we can use it in that fashion. And inside chemistry still there is a huge scope that we can do it. So these are the few tasting and these are the few products. With the help of modern we can change the color. This is actually the constituents of the coconut shell extract. These are lots of so with the help of HPLC and GCMS, we have find it out certain chemicals. These are the groups are there, and these groups are reach active as compared to the water that we have taken. So it is a very good source if you wanted to make the edible coconut water. It is very good source for the pharmaceutical industry. It is as well as it is a very good source as a reducing. It is a very good source for the reducing agent also. So you can think for the reducing agent. So this is actually the dye instead of water. We have used it and we have find the coloration as well as the finishing effect. These these again the different source. There is banana sugar stem. It has also a lot of potential for the reducing as well as the fire retardancy and antibacterial property. At least also has the source. Now I am keeping this arena to alert all the especially in India nowadays. We have found after the COVID, the dengue, malaria has keeping playing a very crucial taking the action and lots of if you go to the newspaper and the media that find the dengue and malaria rate is too high after the COVID. So please, as a chemist, I have request focus on this and few of the research I will try to show you. So this is actually diethyl metatrolate. It is mostly used for the mosquito repellent or the insect repellent finishes. And based on that, these are the few chemicals. Also, we have a natural herbal resource, citronella, castor oil. So most of this oil is also and camphor that we know from the since primitive that it is a very good source for the mosquito and insect repellent. So now the things that now we can use in the fibrous material, how we can use it so that the wash durability and all that can be taken place. So in order to mosquito and coil and this net, if you want to remove, then we have to do the mosquito repellency of the fabric. So these are the transparency repellent that content the mosquitoes mostly work. And based on that, nowadays, Taragad MOS Tarex has developed one chemical and Arcoma. And these are the cone and cage stage mostly done with the mosquito repellency. So this is one research that I have done during my PhD. I have told you. I have found out chrysanthemum as an oil. I have taken out and then with that the evaporator. I hope that being a chemist you easily understand how it's done. So we find out from that particular oil, and then chrysanthemum fragrance is responsible for the mosquito repellency. But what fastness is the issue. So what I have done, Pedica sun binder used it, and along with the coconut shell extract. So use it with the pad dry and pure technology with the different formulation. And what we have found after the pad dry cure technology, we have found mosquito repellency fabric, antibacterial because of the coconut shell extract that we already developed, ultraviolet, aroma as chrysanthemum oil has a very good aroma value and the natural coloration. So only with these minimal resources, we have found so much value addition on the material. So this, if it is a, can be a converted into garment, then we can understand how much value addition onto the material with a minimal cost. So such type of area is always there with the natural resource, and we can think for that activity. So it's actually always it's one type of joke, but we have to really think. So whether we give this type of images or answer to them, how's your first flight? Feels great, Dad. Everyone was clapping for me. So every clapping is not good. We have to understand. So sometimes a few of the clapping also we have to think in the different angle. Now the graphene, that is actually the 2004, it has been discovered, and we know that thicker than copper is a million times than stronger than diamond and more better conductivity than copper. And it is a marvelous discovery, and it is from the graphite. It is can be discovered, and has a potential of the applications as we have discussed. The Samsung and the Apple, most of the automobile industry are trying to discover most of the applications nowadays. Wireless trend, the research and development is going on. So those who want to do PhD and postdoc, so I think the carbon nanotubes and the graphene is a very good scope for you to make a this type of scope. Still, it's not developed. These are the hypothetical this, there. So I hope you can think on this angle. So we know that synthesis of graphene, these are the done. So here in the synthesis, hydrazine and NOx has been used, which is not eco-friendly. We can, this is actually not published yet, but still I try to show you in order to give you the motivation. The natural resources has the potential to act as a reducing agent. So I've used as a green coconut shell extract, banana pseudostem shape, grass seeds, and sugar cane juice. These all has the potential to reduce. So instead of making this graphene oxide to graphene. So NOH and hydrogen, if you remove it or we cannot use it, still it gives you the very good property, the reduced graphene oxide. And we have find it out is a similar graphene that we have found. So after the graphene oxide to reduce graphene oxide. And then I applied on the textile material as a pad technology and we found conductive textiles, antibacterial fight RNC, much more rich in number, and at the same time it is a green chemistry approach, you can say. So I hope as being you are a chemist and polymer world, you are people. So if you combine these two technologies together, you can do really a great change to this arena. Now, few of the just a picture. I hardly take 2 to 3 minutes. Is a textile design approach that textile industry, that fashion industries had done and developed by the fashion college. So this is actually we are not focused only the top of the pyramid, but also for the bottom of the pyramid who have nothing to wear. So we have tried to upcycle the products which are old with the help of the dyeing, printing, and the few of the design technology. These are the few pictures. Then sustainable wedding plan also we have developed where from the wastage of the flower we can do it in the material and again not only with the coloration, eco printing and others for the wedding of the bridegroom and bride, and then again we creating other applications also. So complete sustainable wedding we have planned. Then wastage of the temple and all that wastage we collected wedding and we try to give it in a eco printing, dyeing, and finishing look. And we have found it's also very good for the cost effective as well as the angle. Again, there is a cycling of polypropylene bags and denim fabric. So it is actually a waste, and what we have done convert it into a design part. So these are the few applications we developed, and these are the few garments. This is a polypropylene bag that is actually the wastage, and the denim that is actually different of old denim. So we created into this design, and we so as a design person, so we try to do it in such angle. So I hope in a chemist also we can do it. So these are the few embroidery, katha story. These are the few applications on the fabric value addition. These are the few natural dye fabric, dye with the tea, turmeric, rust of the iron rust. From that, this color has been developed, and we have done. Then turmeric, neem, tulsi. These are the few embroidery work, and it is also we have tried to work on the COVID. That is on the mask. That is with the help of the turmeric, neem, and tulsi. As these sources have very good herbal. It is also another herbal resource, and as we know that is antibacterial property. We not to check or proof it, and we given to the textile fabric, and because of that, its efficiency has been improved. And this goes the microbial resistance, UV protection, and at the same time, 100% eco-friendly process. And nowadays, it has been very good for the COVID time. So that means we should think for the not only for the linear economy or recycling, but also we should do for the circular economy. And if you want to achieve anything, 3P always keep in mind: people, profit, and planet. And only we can do something for a better environment, better future. We can reduce the loss of the footprint, and always we can do the cleaner and greener environment. So in conclusion, we can say we should think for the consumption, sustainability, and I have based on that I've edited one book, Textile Dyes and Pigments, that is a green chemistry approach. If possible, I will try to give it to the ma'am also so that we can. There's lots of scope for the research is there. So keeping in mind, I have written that book, and these are the few publications. These are the few edited books. Functional and textiles and what these are the few about. So I really want to acknowledge and thank you, and sorry for the taking 10 to I think 15 minutes extra, 15 to 20 minutes. So thank you to Professor Arpan sir, Professor Vijay. sir, Professor Kalpana ma'am, for giving this opportunity in such a prestigious forum. Thank you.
Okay, thank you, sir. Uh, some students have raised their hands. Ruchita Sharma, Afreen, and five other students. Ruchita Sharma, do you want to ask something? Ruchita Sharma, you have raised your hand. Want to ask something? Okay, Afreen, do you want to ask something?
Ma'am, it's because of attendance. I thought you were taking attendance. Yes, ma'am.
Okay, okay. Do you have any question? No? Okay.
No,
Well, okay. Any student, anyone else? Nilesh Parihar, do you want to ask any question?
No, ma'am.
Okay. You are raising hands, so I thought that you want to ask some question. Okay. So none of you want to ask any question. Okay, thank you. Bharada sir is there. Sir, are you there? No. Professor Arpan Bharadwaj, are you there? I can't see him. Paris sir, are you there? Actually, I can't see both of them. Okay, no issues.